Hi everyone, in this video I'm going to show you how to assemble the Motor Servo Driver DIY kit and use it with the Quantum system. So let's get started. The 4-motor servo driver DIY kit is an evolved version of our 4-motor kit. It utilizes a pre-soldered PCA 9685 and 2 H-bridge SMT chips to control 8 servos at 5 volts and 4 DC motors up to 25 volts at 3 amps with the Quantum platform. This kit brings versatility and permanence to your maker abilities by only having to build once, and then you're able to use it to control a combination of servos and motors depending on what you need for your project. Before we get started on assembling the Motor Servo Driver, I would first like to show you our documentation for this product. This page will provide you with all the information regarding this product, such as a description of the kit, projects we have made with the kit, and most importantly, the designators to tell you where to solder each component. I will have the link for this page in the description below, or you can also scan the QR code found on the packaging. To solder the components onto the PCB, I'll be following the designators found on the documentation. For example, where it says C8 on the PCB, I will place the capacitor designated as C8 in the documentation and solder it to the board. So now let's get started. Now let's go ahead and connect it to a builder base. I'll be following this schematic here. So once you have finished soldering your DIY kit, this is what it should look like. You can see 8 columns of pin headers here, 1 for each servo. You'll see 4 terminal blocks here, 1 for each motor. You'll have 2 terminal blocks here for the 5-volt power, the voltage to the motors, and then 2 ground terminals. And since we're using the PCA chip here, which uses the I2C connections, we have ground, 5 volt, the SCL line, and the SDA line, which will be connecting to the builder base. So with that being said, let's go ahead and connect our builder base to this DIY kit. So to make this a little bit cleaner to connect, let's go ahead and bring the builder base here. I'm going to flip the DIY kit upside down. That way we'll have the ground terminals at the bottom, the 5 volts second to the bottom, and then the SCL, and then the SDA. So now I'm going to bring in 4 male-to-male jumper wires, and we're going to connect the terminal blocks on this side of the DIY kit to the builder base. I'm going to start by connecting the black male-to-male jumper wire here to the ground terminal on the DIY kit. Then next, I'll bring a red male-to-male jumper wire, connect that to the 5 volt portion of the terminal block on the DIY kit. Then now I'll take the green one and I'll connect that to the SCL terminal here. And lastly, I'll take this orange one and connect it to the SDL terminal. So there we go. We have our 4 male-to-male jumper wires connected to our DIY kit. Now let's connect them to the corresponding terminals on the builder base. First one's going to be the ground. Next one's going to be 5 volts. The green one is going to be the SCL. And then lastly, the orange one will be the SDA. And there we go. So that's how you connect the builder base to your DIY kit. Next, let's go ahead and connect the servos, the DC motors onto the DIY kit, and then we'll go over the different ways you can power this entire circuit. All right, so here is a demo board that I put together for this kit off camera. And as you can see, I've already attached the DC motors and the servos to the board. It's pretty straightforward. You just have the positive and the ground for each motor going into their own terminal blocks. You can see it's labeled on DIY Kit, motor 1, motor 2, motor 3, motor 4. And the same thing goes for the servos. It's pretty straightforward. You have your pin headers. On the side of the pin headers, you can see they're labeled G, S, and P. A little bit small here on camera, so you just hook those up accordingly to those pin headers. Just like that. And there you go. That's how you connect the servos and the DC motors to your circuit. Now let's go over the different ways that you can power this. So the most basic way to power this entire circuit is to use a micro USB cable here, just like the one that's provided with the builder base. You can plug it into the builder base. And then in order to supply the correct voltage for these DC motors, you will have to bridge the 5-volt port on this side of the DIY kit and connect that to the VM port. So the 5 volts is going to come into our builder base here, and that's going to supply the 5 volts to the DIY kit. And then when it comes out, that 5-volt terminal here is going to go back into the VM port and then supply voltage to these DC motors. So that is the most common way to power DC motors in your circuit, especially if you're using 5-volt DC motors. However, if you're using more powerful motors, you can do that. This DIY kit is able to power motors up to 25 volts at 3 amps. So if you're doing it that way, what you can do is go ahead and unplug the micro USB from your builder base. And then what you can do is bring in a flat power supply kit like this one. And this will allow you to connect a 9-volt battery to the supplied pigtail here. And then you can supply 5 volts into this entire circuit from the output voltage here that's already been regulated down. And then you can also use these pen headers next to the barrel jack, and that will provide you with the direct input voltage that you can connect to the VM terminal here, and that will supply your DC motors with the input voltage. So if you have a 9-volt battery in here, you have that connected to the VM, these motors will be running at 9 volts. And if you have the 5 volts from here connected to the 5-volt terminal on the DIY kit, your entire rest of your circuit will be powered with 5 volts, including your builder base. So this is nice to have a portable way to power everything. You don't need to be tied to a micro USB cable. Honestly, I prefer this. However, just keep in mind that the VM voltage is going to determine based on what kind of DC motors you have. So for this video, I have 5-volt DC motors here. So I will not be using the flat power supply kit. I'll just keep the wire here bridging between the 5 volts and the VM. However, you can also have the 5 volts going both into VM and the 5 volts here. Just make sure it's grounded, and that way it'll still give you a portable power source for whatever project you're using. All right, so now what I'm going to do is just go ahead and reinsert the micro USB cable here and power our circuit back on. And then now I'm going to go over to the Q server, pair the builder base, create the firmware, show you a demo app on how this will work. I will also be controlling these DC motors and the servo using this Joystick controller DIY kit. I'll have the documentation linked in the video description below as well on how you can purchase one of these DIY kits, how to set it up, and so forth. But I will not be going over the actual setup of this in this video. Okay, so here we are on the Q server. Let's go ahead and start by pairing the builder base tied to the Motor Servo Driver DIY kit. To do that, go over to the Clients tab, then go to the Unpaired tab, and then you should see your builder base appear in the list. Go ahead and go to Actions, and then go to Pair. All right, so once your client is paired, go ahead and click the Setup button. And then for the name, let's name this Motor Servo Driver. You can name it however you want though. And for the location, I'll just select Office, and then click Save. Now, before we go and build our firmware, since we're using the PCA 9685 I2C chip on this Motor Servo Driver, we'll have to do an I2C scan to make sure we know the I2C address before we build the firmware. To do that, go back to the actions for our builder base here, and then go to Debug, And then under debug, click the I2C scan button, and then you'll see that the address is 40. So once you have that, keep that in mind. Now we can go to the firmware builder, and then we'll create our firmware. I'll also have the firmware we're about to build and the demo app in the documentation that's linked in the description. We're also going to be adding this to the Quantum library, so you can check that out once it's included. But for now, let's go ahead and build it from scratch. To do that, I'm going to click Create New. And for the name, I'll just name it Motor Servo Driver. And now let's go ahead and start by adding the servo hardware pieces. So go to click Add Hardware. We'll search for servo, select it, and for this first one, I will name servo 1. And then click Add Hardware. And then go ahead and click the drop down for it. For the driver, we are going to select PCA 9685. And then for the I2C address, make sure it's the I2C address that you scanned. In this case, it'll be 40. And then for the channel, this is where it's going to get a little complicated. So here is the DIY kit. Remember, it's upside down. So from here, this is going to be servo 1, and all the way to the left will be servo 8. And we're going to have to assign the channels for the servos and also the DIY kit. For the first 4 servos, it's going to be channels 3, 2, 1, 0. And then the DC motors is going to be channels 4 and 5 for motor 1, 6 and 7 for motor 2, 8 and 9 for motor 3, and 10 and 11 for motor 4. And for the last 4 servos, servo 5 is going to be channel 15, servo 6 is going to be channel 14, servo 7 is going to be channel 13, and servo 8 is going to be channel 12. You can also look at this diagram here for all the channel assignments. So with the channels in mind, let's go ahead and continue with the firmware build. So for servo 1 here is going to be channel 3. And now we'll just click Add Hardware again. You can see servo is already selected in the type so that we don't have to search for it again. I'll add in the next servo, which will be servo 2. Click Add Hardware. Again, PCA 9685 is the driver. I2C address is the same. And for this channel, it's going to be channel 2. And then we'll add the next servo, servo 3, add hardware, PCA 9685, I2C address, and then the channel is 1. And servo 4, add hardware, PCA, and then channel 0. Now let's continue with the last 4 servos as well, then we'll move over to the motors. All right, so now we have added all 8 servos to the firmware file. Let's go ahead and add the 4 DC motors. So to continue, just go to Add Hardware, search for motor, select it, and then we'll type in motor 1 for this name. For the driver, we'll be doing PCA 9685 as well. I2C address is the same. For DC1, we're going to use channel 4. DC2 pin is channel 5. Now let's add another motor. This one will be motor 2. Add hardware. Same driver. Now for DC1 pin, that's going to be channel 6. And DC2 pin is going to be channel 7. Now let's add motor 3. Be the same driver. DC1 pin will be channel 8. And DC2 pin will be channel 9. Now let's add the last motor, which will be motor 4. We'll add a hardware. Again, same driver, same I2C address. Now for DC1 pin, that will be channel 10, and DC2 pin will be channel 11. So now we have added all 8 servos and 4 DC motors. Go ahead and click Save. And then we'll go to Actions. Then select Upload, and then we're going to choose the Motor Servo Driver Builder Base client, and then select Upload. Now while that's uploading, I'm going to go ahead and power on my joystick controller. And then the firmware is already uploaded to it, so I'm not going to create that in this video. Just quit out of notifications. We'll go back to clients. I'll go to unpaired and I'll pair that joystick controller. All right, once that's paired, we'll do the setup. I'll just name it joystick and then select office as the location and click save. Now let's go ahead and check out the app for this demo. So we'll go to the apps tab and here's the app. Go to the actions, click edit. Now here we are, here is the demo application. I'll be sharing this with you guys as well. It will be in our library on the Q server, but we'll not be including the joystick hardware objects in this menu arranging. We'll just keep the interface objects to keep it simple for you all. But let's do a quick walkthrough. So here we have our 4 DC motor hardware objects, and then we have the 8 servo hardware objects here. And for the servos, those are going to be controlled by input number interface objects. We can input number in our dashboard between 0 and 180 in order to control the degrees of the servo. Now, depending on what your project needs, you might have to do some servo calibration here. This is why you have the offset ports. And then with our joystick, I have the x-axis of the joystick sending an analog value. It's getting range between 0 and 180 degrees, which will then input the new degree numbers into this input number and then sends it to the servos. And this way we can keep everything all uniform when we try to control it between hardware and interface objects. And then over here, we have the motors. They're being controlled by slider analog interface objects. And you'll be able to create the analog values on the dashboard as well with these guys. And that goes into the joystick axle port of the motor hardware objects, since that will interpret the analog data that it's receiving into a bidirectional control. And then the right joystick hardware object here, I'm going to have the y-axis send out the analog value into these slider analogs and then goes into the motor hardware objects. So that's pretty much the demo app. Let's just double check that the firmware is uploaded. Yes, it is. Now we can just save it real quick. Return to my apps. Now let's go ahead and map all those hardware objects in the application to the hardware in the firmware file. So we'll click that play button. And now for the one that says Motor 3, we're going to choose the builder base Motor Servo Driver and the hardware renamed Motor 3. This one will be Motor 4. This one will be Servo 4, Servo 8, Servo 5, Servo 6, Servo 7, Servo 2, Servo 1, Motor 1, Motor 2, and as you can see, it will only pop up with hardware files that match the type of hardware object. So we don't see the servos, just the motors. So Motor 2 goes to Motor 2. The joystick here goes to the left joystick. Servo 3 goes to Servo 3, and then the right joystick goes to the right joystick. So once you've done that, you can click Save and Run. All right, so here we have the demo board is powered on. You can hear the motors rattling a little bit in the 3D printed housing that I created. Now let's go over to the dashboard on our Q server. Go to that demo app. Now you can see the two different groups. We have the servos and the motors. As you can see, the neutral range here for the motors is 2091. And then for the servos, it's at 86 degrees. Now, if I bring in this joystick here, I can go left and right with the left joystick here, and you can see these servos are moving. So if I go to the left, it's going to go one direction. I release it, it goes to the 90-degree position. And I go to the right, it goes to the opposite direction. And then for the 4 DC motors, I'll be using this right joystick. If I go forward, you can see it spins in one direction. If I go back on the joystick, it'll spin the other direction. And since I connected the joystick hardware objects to those interface objects before they get inputted to the servo and DC motor hardware objects, if you look at the dashboard, you should see that as I move the joystick on my controller, it's also changing the data on the dashboard, and so forth. However, if I want to just control it from the dashboard, I'll go to the dashboard here, say I want servo 1 to turn to 120 degrees. There you go. Now you can see servo 1 turn 120 degrees. Say, and then if it's at 0, it moves to 0. If I type in back to 86, it'll be in the same motion here. Say I want to do that for servo 3. I want it to be 180. It moves to 180. If I don't have an input, I'll go to 0. And then we'll put it back at 86. Now say if I want to spin motor 2 here, I'll just go to the slider analog with motor 2 labeled on it. And I'll move the analog slider one direction. And then I'll move in that direction. Now if I go the other way, and it spins the opposite direction. So those are two different ways you can control these hardware components. One from the dashboard using the interface objects, and then the second is from another piece of hardware component like this joystick controller. So it's pretty versatile on what you can do with it. You can use a number of combinations of motors and servos for your project. I'll be planning to do some projects with this DIY kit as well. Overall, it's pretty cool. So I'm excited to see what you guys end up using this kit with. So be sure to share it with us. We would love to see it. So that's how you assemble the Motor Servo Driver DIY kit and use it with the Quantum system. Make sure you check out those links in the video description below for more information about this kit and other information that we have discussed. Hope you enjoyed this video, and thanks for watching.